All right, good day, guys. It's Mr. Matsilele, your FIT lecture. I just want to, I just want us to continue from where we ended last time. So before the lockdown, we were talking about data representation and data storage. Data representation and data storage. But now, I just want us to recap something before we continue from where we ended. If you still remember, last time I told you that the learning objective of this chapter, after this chapter, you must be able to define the unit bit, you must be able to define bytes, kilobytes, megabytes, and you must know how data needs to be converted into binary format in order for it to be processed by a computer. You must be able to convert a positive binary or a decimal number into 8 binary numbers, and you have to do it vice versa. So we'll do a lot of converting from binary to decimal, from hexadecimal to octal. I told you about in class. So if you still remember what I told you in class, I told you that computing is all about data representation. So computing is all about data representation, data storage, data processing, and data communication or data transmission. So when we talk about computing, we are talking about data representation. It's all about data storage, it's all about data processing, it's all about data communication or data transmission. So guys, so in order to understand how a computer processes data, it is very much important for all of you to know how a computer represents that data. So if you want to understand the whole thing about a computer, how computer processes data, so the first thing that you have to know is you must know how this computer represents it before it processes it. So we must know how the computer represents this data before the processing part. So guys, you must know that computers are digital. Computers are digital. They only recognize only two states, which is 0 and 1s, and we can call it on and off. So computers are electronic device, and you know that all the electronic devices that are powered by electricity. So it means that they have only two states, which is on and off, like what is showing here. So it's on and off. When it's on, in computer is represented as 1. So and when it's off, is represented as 0. This is what we did in class. So I'm just reminding you. So guys, unlike human being, I told you that computers are digital, and we have seen it from the previous slide that computers only recognize these two discrete states, which is 1 and 0. So your data can be in this format. If you check here on this side, it's ABC, it can be weather, it can be 1, 2, 3, whatever the text that you have given us. Sometimes you see pictures and everything, but inside the computer, this information or this data, your data, is represented as 0 and 1s. So sometimes when you type A in your keyboard, this is not what computer recognizes. Computer only recognizes 0s and 1s. So this is your data, and this is computer data. So I showed you in class, if you all still remember, that we did all these things. So I'm just reminding you before we go to the part of conversion, because when we end the class, we were talking about converting. Because if you check on our objective, we say you must know how to convert positive whole numbers into binary. You must know how to convert the binary and the decimal number ordinary into positive hexadecimal number. So we were coming to that part of conversion where we were doing the conversion. So we'll just go straight to that part. So guys, before we do the conversion. This is just a reminder. I just want to remind you of this number system that we have, that I told you that if you check on your calculator, there are 3 button or 4 buttons that sometimes maybe you don't use. You just see them: return bin, return oct, decimal, and hex. So these are the number system. We have the number system that is called binary, and the binary is represented by base 2, and it only have 2 digits, which is 0 and 1. And the octal number system is of base 8, which is represented by the digits 0 up to 7. And the decimal number is of base 10, and it's represented by the digits 0 up to 9. And the hexadecimal numbers are of base 16, and is represented by the digits which is from 0 up to F. So, and I told you in class, you still remember that when it counts after 9, when it says 10, 11, 12, 13, 14, 15, so 10 is represented by A, and 11 represented by B, 12 represented by C, 13 represented by D, 14 by E, and 15 by F. So this is what we did in class. So we will come to the part of conversion. So guys, if you check on our lecture notes, on page 36, it's on page, let me just show you the page number. It's on page 36, where it talks about data representation and data storage. So we are just going to the part where we're talking about the conversion. So guys, just note of this here, that you can be given a decimal number that you need to convert to binary, or you can be given a binary number that you have to convert it to a decimal number. And conversion of binary number to decimal can be carried out as follows, and I showed you in class that this is how you convert binary number into decimal number. And always remember, you should note that when converting binary number to decimal form, you should always start counting from right to left. This is the thing that you must always remember. You count from right to left. So I'm just going to show you again how to convert from binary number to a decimal number. Then we'll also do the other conversion. So let me just give you a recap of how we come up with this 45. How we come up with this 45. So we are given 1 0 1 1 0 1 1 0 1 1 0 1. So okay, let's just do it. Okay, we are given what is the number? It's 1 0, given 1 0 1 1 0 1 1 0 1 1 0 1. Okay, it's 1 0 1 1 0 1, and we know that this one is of base 2. So we want to convert it, this one, to base 10. We want to know the decimal number of this 1 0 1 1 0 1. Mind you, I told you that this is the computer data. So computer data, we are given 1 0 1 1 0 1. So we want to know, or this digits, it represents which decimal number. So we are going to convert this, and we are going to work together. I told you that when you count these digits, you must start from the right to the left. So just check how many digits do we have. There are the digits that we have here is 1 2 3 4, and let me just get the pointer, so at least you will be seeing what I am doing here. Okay, let me just, we have, this is digit number 1, and this is digit number 2, this is digit number 3, this is digit number 4, this is digit number 5, and this digit number 6. So when you want to convert this, okay, we understand that now we have 6 digits. So converting from this one, it's done this way. Because if you still remember, the decimal number on our notes, I will just show you that the decimal number, it has 10 symbols, and those symbols, or it has 10 symbols or digits, and we say, and those digits, they start from 0 up to 9. The maximum value of a single digit is 9, so it's from 0 to 9. So this is what we're going to do now. Let's just work on how to convert this binary number to a decimal number. So now I'm going to rub these ones. I will just show you that we have 6 numbers. So this is what we are going to do. You will say, then you will say 1 multiplied by 2 to the power 5. Because if you remember, our digits start from 0, 1, 2, 3, 4, 5. So it means that here, let me just write it so that at least I don't just show you something that you can see it on the board. So this one, it means that the first digits, we say we count from the right to the left. So it means that the first is 0. Okay, sorry. I just want to push this one down. Okay, the first one is 0, and this one is 1, and this one is 2, this one is 3, this one is 4, and this one is 5. So now the last digit, the first digit is 2 to the power 5. So we say 1 multiplied by 2 to the power 5 plus 0 multiplied by 2 to the power 4 plus 1 multiplied by 2 to the power 3 Let me just make it smaller a little bit so that everyone can see. Let me just write it this way. I hope now you can see. Then we say plus 1 again. Remember, this 1 here is the first number here. This is 1, and this is that 0 that we are talking about. And the other one is this one that we are talking about, and the other one is the one that I'm going to write here, which is 1 multiplied by 2 to the power 2 let me just make it a little bit small. Okay, I hope it's clear now. Then we say plus, we have another 0 multiplied by 2 to the power 1. Then lastly, fine. Lastly, we have 1 multiplied by 2 to the power 0. Alright, so here we are. So this other 0 here is this one, and the last one is this one. So here now, it means that the first part, let me just put an equal sign here so that you will see. Let me just put an equal sign. It's an answer. We are answering the question that says convert this binary number, which is 101101 base 2 to base 10. So let's calculate. 1 multiplied by 2 to the power 5. It's 2 to the power 5 is what? You can use your calculator, and I'm sure that it's all of you by now you know what it means. 2 to the power 5. 2 to the power 5 is the same as 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. It means that it's the 2 multiplied by 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 2 5 times. So here we have 30 2 plus, because this is 0 multiplied by 2 to the power 4 is 0, plus 1 multiplied by 2 to the power 3. 2 to the power 3 is 2 multiplied by 2, which is 4 multiplied by 2, which is 8. So it means that here we have 8, plus here is 1 multiplied by 2 to the power 2, which is 4, plus this one, because it's multiplied by 0, is 0, and the last one 2 to the power 0 is 1, so it means that the last one is 1. Then the answer for this one is you count 32 plus 8 plus 4 plus 1, which is 45, which is 45. So this is 45, and it's of base what? It's of base what? 10. So it means that we say therefore 101101 base 2 it's equals to 45 base 10. Then this is the answer. This is the final answer. So I'm sure that this one you know. So now on our next session, I'm just going to show you how to convert from decimal to binary, and from binary to octal to hexadecimal, and we will do vice versa. So now I hope by now you understand that what we were doing here on this first part. So now we are just going to move to our second part, where I'm just going to give you a question that says convert the following decimal number into its equivalent binary number, and you also have to convert it the same number to octal and to hexadecimal, and we'll do vice versa. This one is just a revision because we already did it in class, so I was just doing a revision with you. And I told you that if you want to do this calculation first, the simplest way of doing it, let me just also show you now. The simplest way of doing it, let's say now you are given 1101 base 2, and they say convert it to a decimal number, and I told you that the easiest way to write it, you can just write it this way, and it is simple and straightforward. We say we count it from the right to the left, so we know that this one here, let me just use another color. Let me just try to use this one. So this is what you can do. You know that this one is 2 to the power 0, and here is 2 to the power 1, and here is 2 to the power 2, and here is 2 to the power 3, and here is 2 to the power 4, and here is 2 to the power 5. So what you do now, you will say, on the first part you will say, let me just want to move it a little bit up. So on this one, on the first part here, it's you will say 1 multiplied by 2 to the power 0. So we are on this part. On this part here, it's 1 multiplied by 2 to the power 0 is what? It's 1. Well, 2 to the power 0 is 1. Then the other part is 0. Okay. I'll try to use different color. On this one, it will be 0 multiplied by 2 to the power 1. Any number multiplied by 0 is 0. Then plus. On this part here, 1 multiplied by 2 to the power 2, and it's 4, which means that here we have 4. And then in this part is 1 multiplied by 2 to the power 3, which is what? 8. Plus. In this part, 0 multiplied by 2 to the power 4, any number multiplied by 0, we know that is 0. Plus. The last part, it's 1 multiplied by 2 to the power 5, which is what? 32. So if you count all this one, we get 45 of base 10. So this is your answer. So I hope you understand by now. So let's just move on to the second lesson. Sharp for this one. The first one will be done. Then we are going to do the question and answer on the next lecture.